Hi, my name is Schottky bin Muhammad Mazuki and my matrix number is 192448.
My name is Muhammad Faizuddin bin Kamarudin. My matrix number is 191852.
My name is Muhammad Jazlan bin Rela. My matrix number is 192202.
Okay, we have assigned from Dr. Nur Amzia about assignment. That is the topic is the Schottky diode and Schottky barrier.
So let's move to the slide. Hello everyone, so today I want to talk about the introduction of Schottky diode and Schottky barrier. As we see in this slide, the symbol of Schottky diode has anode and cathode. Schottky diode is an electronic component that is also known as barrier diode or hot carrier diode. Schottky diode is named after the German physicist Walter H. Schottky. P-type semiconductor is placed by metals such as platinum, aluminium, and also gold. So the junction was formed between the metal and the semiconductor, which also known as metal semiconductor junction or MS junction. Schottky barrier is a potential energy barrier where the electron have put all the communities potential energy barrier to across the diode. Schottky diode has two properties, that is, has lower turn-on voltage and also quick response time. I will talk about this later in next slide. Let's see in this slide. In this picture, there is a metal and N-type semiconductor joined together to form MS junction. So in a normal PN junction diode, a P-type semiconductor and N-type semiconductor are used to form the PN junction. When a P-type semiconductor is joined with N-type semiconductor, the junction is formed between the P-type and N-type. This junction is known as PN junction. In Schottky diode, metals such as aluminium or platinum replace the P-type semiconductor. When aluminium or platinum is joined with N-type semiconductor, a junction is formed between the metal and N-type semiconductor. This junction is known as metal semiconductor junction or MS junction. A metal semiconductor junction formed between a metal and N-type semiconductor create a barrier or called depletion layer known as Schottky barrier. Okay, let's look at this slide. I said before this that I will explain more about the quick response time and low turn-on voltage of Schottky diode. So, Schottky diode has less reverse recovery time for electron in N-type to transfer to P-type and vice versa, because it has no space charge region. I will explain about this. It is also called quick response time. Schottky diode can switch on and switch off much faster than other diode such as PN junction diode. This helps the Schottky diode make it very useful in high-speed switching power circuit because of the quick response time. After that, Schottky diode also has a low turn-on voltage. When sufficient voltage is applied to the Schottky diode, current start to flowing in the forward direction. Because of this current flow, a small voltage loss occurs across the terminal of the Schottky diode. This voltage loss is known as voltage drop. For example, silicon diode has voltage drop from 0.6 to 0.7, while Schottky diode only have drop from 0.2 to 0.3. Therefore, the Schottky diode consume less voltage to turn on. Okay, let's see in this slide. So we look at this picture. This picture is explain about the form between semiconductor and metal to form a Schottky diode. As I said before this, when aluminium or platinum metal is joined with N-type semiconductor, a junction is formed between the metal and N-type semiconductor. The junction is called metal semiconductor junction or MS junction. a metal semiconductor junction formed between a metal and n-type semiconductor create a barrier. Okay, next, Schottky barrier diode. As we see in this picture, Schottky barrier diode has two: first, reverse bias when voltage apply, and forward bias when voltage apply. So I will explain about this more deeply. First, forward bias Schottky diode. If the positive terminal of the battery is connected to the metal and the negative terminal of the battery is connected to the n-type semiconductor, the Schottky diode is said to be forward bias. When a forward bias voltage is applied, the Schottky diode, a large number of free electrons are generated in the n-type semiconductor and metal. However, the free electron in n-type semiconductor and metal cannot cross the junction unless applied voltage is greater than 0.2 volts. If the applied voltage is greater than 0.2 volts, the free electron gain enough energy to overcome the void in voltage of the depletion region. As a result, electric current start flowing through the Schottky diode. If the applied voltage is continuously increased, the depletion region become very thin and finally disappear. So next, for the reverse bias Schottky diode, if the terminal of the battery is connected to the metal and the positive terminal of the battery is connected to the n-type semiconductor, the Schottky diode is said to be reverse bias. When reverse bias is applied to the Schottky diode, the depletion will increase. As a result, electric current stop flowing. However, a small leakage current flow due to thermally excited electron in the metal. If the reverse bias is continuously increased, the electric current gradually increase due to the weak barrier. If the reverse bias is largely increased, a sudden rise of electric current take place. This sudden rise in electric current causes the depletion region to break down, which may permanently damage the device. So that's all for reverse bias and forward bias when voltage is applied.
Hi everyone, my name is Faiz. So I would like to continue from where Jazlan has left us before, after the Schottky barrier diode. From before, we have learned that Schottky barrier diode can be affected by the type of voltage applied, whether it's a forward bias or a reverse bias voltage. So you might have been wondering, what are the other factors that can affect its semiconductor metal junction? So I would like to tell you guys there are three factors that can affect it. Firstly, we have the presence of electric field due to the presence of electron at a distance, which is also known as image charge. Secondly, we have the interface state, or all known as Fermi level pinning. And lastly, we have current voltage relationship to the diode, to Schottky diode. Before continuing, I would like to tell you that guys, that the Schottky barrier diode mentioned before is in its ideal condition. Now I would like to tell you what it will come when there are other factors affecting it. Now I will tell you about the first factor, which is image charge. So what is image charge? Image charge is a condition when there is an electric field near metal, which will cause the potential barrier inside semiconductor diode to become lower. This can be seen from the graph, from the image included from the video. There is a green graph and the red graph. The green graph shows what will become to the graph if there are no external factor or electric field near the diode. But the red graph shows the effect of electric field to the diode when it is nearby. As you can see, the built-in potential barrier is become lower due to the electric field, but the effect is very small. We will proceed with the other factor that affect Schottky diode. We now have the interface state. So, what is the interface state? Interface state is also known as Fermi level pinning, which come from the word Fermi energy level, which carry out the means that energy difference between highest and lowest occupied single particle state. From this video, we can see that the highest level is the metal, while the lowest level is in the semiconductor. Now, I will explain what is effect to the diode. We have seen that there's a neutral state. Below it, we have the donor state, and above it, we have the acceptor state. The donor state, as I mentioned, will become neutral if the state contain an electron and positively charged, but the amount of electron must not exceed the amount of positively charged particles, so it will become term equal. Now we will tell about the acceptor state. For the acceptor state, it must not contain any electron or any negatively charged particle if the state contain its own electron. So I will tell what is the effect if the difference between the neutral level and the donor state is very large. If when it's very large, the addition or subtraction at that region is being neglected, as it won't change Fermi level as it is being pinned. Now we will proceed. What is the effect of interface state to the Schottky barrier height? When the neutral state is reaching infinity, the barrier height is now fixed by the band gap energy and the potential delta naught, which is the difference between the neutral state and the donor state. The barrier height is totally independent of the metal work function and the semiconductor electron affinity, which cause the infinity level become pinned at the neutral state. After explaining the effect when the surface state approaching infinity, I will tell you what is the effect when the surface state approaching to zero. This will cause the difference between the neutral state and donor state, and its accepted state is become non-existent, which will become like in the ideal condition. Last factor affecting Schottky diode, I will pass it to one to explain about the current voltage relationship with the Schottky diode. That's all. Thank you.
Hi, my name is Wan Anas, and I will continue with Faiz slide, which is the third factor affecting Schottky diodes, current voltage relationship, or IV relationship for short terms. In these factors, of course, we will look through the current and voltage measure from conduct Schottky diodes. As we can assume that barrier height is larger than kT, which is the energy of the product of Boltzmann constant and the temperature. As we can see from the graph, for forward directions, the current rises exponentially, having a near or turn-on voltage around 0.2 volts. For reverse direction, there is a greater level of reverse current than that experienced using a more conventional p-n junction diodes. Now we have reached for the conclusion of our topic, as all that we discussed is all about the Schottky diodes working and its working principles. The Schottky diodes can be affected by three factors that we have told you guys, which is image charge, interface states, and when barrier height is greater than kT in IV relationships. As for application, Schottky barrier diodes can't be used in big detector circuits. It will damage the circuits in no time. Schottky barrier diodes use low power and can be used in high frequency circuits. So we know the reason why Schottky diodes are no longer used in manufacturing nowadays. Hope you guys understand the video well, and don't forget to comment and share to your friends. That's all from us. Goodbye.